Ever wondered what solid principles in object-oriented programming are? Well, you're in for a treat today. Think of these principles like the 5 commandments of coding. They guide you towards creating more manageable, maintainable, and scalable software. So buckle up and let's dive into the fascinating world of solid principles. First up is the single responsibility principle. Imagine you're at a bakery. Each staff member has a specific role. The baker bakes, the cashier handles money, and the cleaner keeps the place tidy. If the baker started mopping the floor, things would get chaotic, right? That's what the single responsibility principle is all about. In programming, each class should have one and only one reason to change. This means each class should only have one job or responsibility. It makes your code cleaner and easier to understand. Next, we have the open-close principle. Picture a beautifully designed, high-quality watch. It works perfectly and keeps time accurately. Now, if you wanted to add a new feature, like tracking your steps, you wouldn't tear the watch apart. You'd add an attachment or a new component. That's the spirit of the open-close principle. Software entities should be open for extension but closed for modification. This means you should be able to add new features or functionality without changing the existing code. The third principle is the Liskov substitution principle. Let's think about a classic game of chess. You can replace the queen with any other piece and the game still makes sense. You can't do the same with the king, as the game's rules change. In the world of programming, this principle states that in a program, if object A is a subtype of object B, then we should be able to replace B with A without disrupting the behavior of our program. The fourth one is the interface segregation principle. Imagine going to a restaurant and receiving a single enormous menu for drinks, food, desserts, and the kids' meals. It would be overwhelming, wouldn't it? Instead, restaurants break it down into separate menus, making it easier for customers to choose. Similarly, this principle suggests that larger interfaces should be split into smaller ones, so that a client will only have to know about the methods that are of interest to them. Finally, we have the dependency inversion principle. Think about the power outlets in your home. No matter what device you plug in, they all use the same outlet. The outlet doesn't need to change to accommodate each device. In programming, high-level modules should not depend on low-level modules. Both should depend on abstractions. This allows for easier maintenance and future changes. In conclusion, the solid principles are an integral part of object-oriented programming. They help to make your code more understandable, manageable, and flexible. Remember, every class has its job. Don't modify what you can extend. Subtypes must be substitutable. Segregate your interfaces and depend on abstractions, not on concrete details. With these principles in mind, you're well on your way to becoming a more efficient and effective programmer. Now go forth and code.